I'm Dr.J Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss about Bayes' theorem. The scientist Bayes introduced this theorem to find the probability of indifferent ways. What is the statement of Bayes' theorem? See, before going to discuss the Bayes' theorem, we have to know what are the mutually exclusive events. If any two events A1, comma A2, the two events are said to be mutually exclusive events, that means there is no common point between them. There is no common point between the given two events A1 and A2. That means A1 intersection A2, that means common point, is equal to pi. Pi means null set. A1 intersection A2 equal to pi. Then we can call as A1 and A2 are mutually exclusive events. Mutually exclusive events. Now the statement of Bayes' theorem is, if E1, E2, E3 and so on En are mutually exclusive events, that means there is no common point between any two events from E1 to En. And A is any arbitrary event. This is not mutually exclusive event to other events like E1 to En. That means if I take any sample space, this is the sample space, assume that any random experiment consists of all the events in this sample space. Suppose if I take A1 here and A2, A3, A4, so on, A5 and AN. Observe that in this diagram, A1, A2, A3, A4, A5 and so on, AN are mutually exclusive events. See, A1 and A2, there is no common point. A1 is separate, A2 is separate. Similarly, A2 and A3 also there is no common point. A1, A3 also no common point. A1, AN also no common point. So that's why these are mutually exclusive events. And another event is there, A. This is an arbitrary event. This is not mutually exclusive event. Assume that this is A. That means A1 and A are not mutually exclusive because there is a common point here. Similarly, A2 and A also not mutually exclusive events. Like that, we have drawn the event A. But remaining all events are mutually exclusive events to each other. Then we have to show that P of EI by A equal to this reverse right side. P of A by EI into denominator EI. By the same, numerator is also equal to denominator, but it's a summation from I equal to 1 to n. Suppose only three events are there, assume E1, E2, E3. I want to get P of E2 by A, where I equal to 2. If I want P of E2 by A, what is the value? Right, P of A by E2 into P of E2 by sigma I equal to 1, 2, 3. Because total number of mutually exclusive events are 1, 2, 3. I equal to 1, 2, 3 P of A by EI into P of EI. That means the denominator value we can expand from I equal to 1 to. So this is we are going to prove in Bayes' theorem. So this is the statement of Bayes' theorem. If E1, E2, E3 and so on, En are mutually exclusive events and A is any other event, then we need to prove that P of EI by A equal to reverse P of A by EI into P of EI by sigma P of A by EI into P of EI. How to prove this one? So according to this diagram, we have to write first S means sample space. Can I write S equal to A1 plus A2 plus A3 plus A4 plus A5 plus A? That means union. E1, E2, not A1, E1. E1 or A1, both are same. Assume this is E1, E2, E3, E4, different E5, En. Add all them, will get sample space. Yes or no? Any random experiment, combined all the mutual exclusive events will get the sample space. Because all they are mutually exclusive events. So we can write as S equal to E1 union E2 union E3 and so on. Now, consider A intersection S. What happened? In this diagram, this is S, this is A. A intersection S will be A only because A is a subset of S. No? That point I have taken. That means A first you write left side, A equal to A intersection S. A equal to A intersection in the place of S, I am going to write this one. E1 union, E2 union and so on, En. Because S equal to sum of all the mutual exclusive events. Now, A intersection, we have one formula in intermediate level. A intersection B union C equal to A intersection B separately union A intersections. Suppose if you have 3 B union C union D, in that case union A intersection. Like that we can expand A intersection E1 union A intersection E2 union A intersection E3 union and so on A intersection En. Got my point? So A equal to, now we have written A intersection E1 union A intersection E2 union A intersection E3 and so on A intersection En. After getting A, you can add P on both sides. P of A equal to P of A intersection E1 union A intersection. Just we added P on both sides. But you observe that in the diagram, A intersection E1, this is E1, this is A. This is the A intersection E1 part. A intersection E2 part, this part. A intersection E3, this part. These all are also mutually exclusive because there is no common point. A intersection E1, A intersection E2, A intersection E3. That point I written. They are also mutually exclusive units. This one, this one, this one. Then we can separate plus. So P of A intersection E1 union A intersection E2 equal to P of A intersection E1 plus, instead of union we can take plus P of A intersection E2 plus P of A intersection E3 and so on P of A intersection union. Because they are mutually exclusive events. Assume this is one. So P of A value we got it. P of A value we got it. P of A intersection E1 plus P of A intersection E2 and so on. But actually what we require in Bayes theorem, P of EI by A we need to prove. But according to the conditional probability, this can be written as P of A intersection EI by P of A. According to the conditional probability formula which we have discussed in the earlier sessions. Now, P of A intersection EI also can be written as P of AI into P of EI. Because, see, P of A by EI, according to the conditional probability, P of A intersection EI by P of EI. But if I want this term, we can multiply these two. P of A by EI into P of A by. This P of A we can write as like this. From 1. That is this one. This P of A intersection E1 also can be written as A by E1 into E1, A by E2 into E2, A by E3 into E3, and so on A by En into En. This can be written as sigma equal to 1 to N, denominator P of A by EI into P of. Therefore, P of EI by A equal to reverse P of A by EI into P of EI by sigma I equal to 1 to N P of A by into P of EI. This is the Bayes theorem proof. Now, we'll discuss one problem on Bayes theorem. This will be very easy. The problems on Bayes theorem, you should remember P of EI by A formula 1. First we listen. The concept of the problem 1. Box 1, box 2, box. 3 boxes are there. Each box 2 white and 3 black. First box. Second box 4 white and 1 black. Third box 3 white and 4 black. One of the boxes is selected at random. Out of 3 boxes, we need to select only 1 box. And 1 ball is drawn from at random. It's to found to be white. You choose 1 ball from the boxes. Find the probability that that white ball is drawn from the box 2. That we need to find out. See, totally 3 boxes are there. You can assume 3 events. Given E1, E2, E3 are events of box 1, box 2, box. What happened P of E1 now? Out of how many boxes? 3 boxes. Probability of selecting 1 box is 1 by 3. Similarly, P of E2, 1 by 3, P of E3 also 1 by 3. So that means box selection over. Now, ball selection. That we can assume. A be the event of selecting which ball? White ball. Now I want to find out probability of white ball because A is a white ball from box 1. How to select? In box 1, how many balls are there totally? 2 white and 3 black balls. How many balls we need to select? 1 ball. How many ways in the denominator? 5C1. 5C1. By. What about 1 white ball from 2 white balls? 2C1. So P of A by E1 is 2C1 by 5C1. That means probability of selecting white ball from that one. Total number of balls are 5. We need to select 1 ball. How many ways? 5C1. Denominator. Because total number of balls are 5. But white ball is required. Now how many white balls in the box 1? 2. How many we require? 1. So 2C1 by 5C1, which is 2 by 5. Suppose if the same white ball, if you select from the bat 2 or box 2, how many are there in box 2? Totally 5. 5C1 denominator. 1 white ball from 4 white ball. So 4C1 by 5C1. Now you select probability of white ball from box 3. How many balls are in box 3? 7. How many balls are required? 1 ball. Which ball? White ball. How many white balls are there? 3. How many we select? 1 ball. So 3C1 by 7C1. So 3 by 7. Now, so bag selection over or box selection over, ball selection also over. Now, if I want to find P of A, that means probability of selecting white ball from any one of the box. P of A means probability of selecting white ball from any one of the box. But in the problem asked that probability of selecting white ball, it should be in the second box. That is P of E2 by A. P of A means probability of selecting only white ball from any one of the box. You should remember. The probability of selecting white ball from box 2. In case the problem consists of box 3, P of E3 by A. Box 1, E1 by A. Only 2 problems are there in Bayes theorem. Either you selecting probability of ball selection, here ball selection from particular bag. So P of E2 by A, according to the Bayes theorem, EI by A by EI into P of EI by sum. A by E1 into P of E1 plus P of A by E2 into P of E2 plus P of A by E3 into P of E. Simplify it, we'll get the answer. So in Bayes theorem, we have 2 types of problems. P of A problem and P of EI by A problem. Probability of selecting ball. Probability of selecting ball from particular bag. But here if you observe, there is a difference. P of E2 by A and A by E2. E2 by A means getting white ball which is coming from back to A by E2 means selecting back to first then getting white ball. This is only we are going to find out in the Bayes theorem. E2 by A, E3 by A, E1 by A. Okay? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.